Welcome to Brain Vision.
Our question says, use table 3 to estimate the total number of protons or neutrons in A, a bacterium, B, a DNA molecule, C, the human body, and D, our galaxy. So I wrote down the values given to us in table 3 here. One bacteria is approximately 10 to the minus 15 kilograms. I abbreviated bacteria as BAC. One DNA molecule I write here is on the order of magnitude of 10 to the minus 17 kilograms. One human, which I abbreviate as H, is on the order of magnitude of 10 to the second kilograms. One galaxy, which I abbreviate as GAL, is on the order of magnitude of 10 to the 41 kilograms. And one proton or neutron, which I abbreviate as P plus or N0, is on the order of 10 to the minus 27 kilograms. So it wants us to find the number of protons or neutrons in the following things. First, for part A, it wants us to do it for the bacteria. So in order to do that, we're going to convert from the amount of kilograms per bacteria to the amount of protons and neutrons that are in that bacteria. So we know that there is 10 to the minus 15 kilograms in every one bacteria. Okay. Oh, and also I should mention, in order to do this, we are assuming that the entirety of the bacteria, human, DNA molecule, whatever it is made up of protons and neutrons. We can do this because the protons and neutrons are extremely large relative to the size of the electrons. So we're just assuming it's all protons and neutrons. So we'll take that and we'll multiply it by the 1p plus, or n minus, we'll just write slash, not n minus, I'm sorry, n0. 1p plus or n0 is 10 to the minus 27 kilograms. So you'll see that the kilograms cancel out, and all you will be left with is protons and neutrons per bacteria. And actually, I'm going to scoot over this C and D here so we have just a little bit more room. Okay. So we'll write that out, and that gives us, it's going to give it to us as 10 to the 12 protons, P plus, or N to the 0. Okay, and I'm actually just going to move this over just a little bit more. Okay, so now we can go ahead and box that in because that's our solution to part A. Part B, we're going to have to do the exact same thing, except for now we're doing it for the DNA. So for the DNA, we have 10 to the 17, or I'm sorry, 10 to the minus 17 kilograms for every one DNA molecule, right? Okay, and then we're going to multiply that by our conversion here between protons and the number of kilograms in a proton or a neutron. So in one proton or neutron, there is 10 to the minus 27 kilograms, right? Same as before. Do that, carry that out. That gives you 10 to the 10 protons or neutrons. Okay, box that in as our solution to part B. Let's do that because we're going to write through the 10 there. We don't want to do that. Okay, so now moving on to part C, we're going to do the same thing except for humans. So we know that there are 10 squared kilograms for every one human. And then you multiply that by our conversion, which is for every one P plus or N0, you have 10 to the minus 27 kilograms. Right? And that is going to be equal to 10 to the 29 protons or neutrons. Okay, and box that in as our solution to part C for the amount of protons and neutrons in a human. Now, lastly, we want to find the number of protons or neutrons in a galaxy. So there are 10 to the 41 kilograms for every galaxy, right? And we'll multiply that by, again, exact same conversion of the number of protons for every the number of kilograms for every proton and neutron. So for every proton or neutron, it's 10 to the minus 27, just as before. Oh, let's write that in a way that's legible here. Kilograms as before, okay. Carry that out. You find that that's equal to 10 to the 68 protons and neutrons. For every galaxy. And box that in as our solution to part D.